So, as we rapidly move to electrify our existing homes, we can't forget that there are some barriers to do that because of our existing breaker boxes may not be able to handle all of these loads. When we want to add things like heat pumps, as far as heating, cooling, water heating, dryers, induction stoves, EVs, solar panels, and more, those are all things we have to deal with load management. And while the Inflation Reduction Act homes rebates in the United States may help cover some of these costs and pay for full electric breaker box upgrades, these funds are ultimately limited and not accessible to all. So, for the meantime, join us today to learn more about these new ways we can electrify that make it more affordable for everybody. Now, before we get started, I want to say a shout out to and a huge thanks to our platinum sponsor, Ream. And speaking of load management, they make it a lot easier to swap out existing gas water heaters to heat pump water heaters to decarbonize because they have 120-volt plug and play systems that can just plug right into your standard outlet. And then you don't need to worry about any of this other demand management stuff. However, you may want to go for the full 240 volt like I did several years ago. And then it has the backup electric resistance heating elements in case you need that little extra boost. And then you may be needing to deal with these improvements that need to occur for demand management. But regardless, whichever one you want to use, you can heat water the most efficiently up to 400% and decarbonize your water heating, reducing costs. So go check them out at greenhomeinstitute.org/REAM-HPWH. So I want to welcome everyone to your electrical panel, Demystified Load Management for Home Electrification. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little here, and I am the education manager. This course is approved for multiple continuing education units, and we got a few too many there on our Certified Green Home Professional one, but we definitely have got energy and materials as two of those for the CUs for us. And then AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out that 5-digit Passive House CU code at the end as long as you're here for the entire CU approved hour. So with that, I am excited to hand it off to our guests here today, Jane Chen and Brian Lamort, who are going to be taking us through this presentation. And so Jane, Brian, welcome. Thanks for joining us, and please take it away.
Awesome. Thanks for having us, Brett. It's an honor to be here. One of our favorite topics about the electric panel. I'm just going to share a few slides, but before I get started, wanted to just give a quick intro. So my name is Jane Chen. I'm the co-founder and CEO of a company called Stepwise Electric, and we make load management solutions that allow individuals to electrify easier, faster, and more affordably. And we really believe in making electrification accessible to everybody. I've spent the last 7 years in this EV charging home electrification space, and I used to help people install EV chargers in the greater Boston area. So good to be here. Brian?
Hi, I'm Brian Lamort. I'm owner of Lamort Electric Heating and Cooling. I've been running a business for 16 years. I've been a licensed electrician most of that time, also licensed in HVAC. We're also now members of the union. I'm very proud about that. And I've had grid stability and demand management and things along that line as a priority that I've been focusing on for years now because I saw the problems we're facing coming down the road.
Fantastic. Well, guys, we're going to try to make this session as interactive as possible. But before we get into the content, we did want to run a quick poll just to assess everyone's level of familiarity and experience with electric panels and home energy. So Brett, I'll let you take this. Most people are novice level, and we have a decent split between folks who have no experience and those who are very experienced. So this will be a fun challenge for us. We're going to try to cover the basics quickly and then get into the fun stuff around load management. I think just to add one more point of context here, today we want to show you guys that not all electric panels are made equally, but that there's a lot more potential in our existing infrastructure than we think. And so if you ever are like, oh, my panel doesn't look good, or I think I need to get that upgrade, and you're not sure, well, chances are there's a better alternative than that electric panel upgrade than that your electrician or folks around you are telling you about. And so we want to help you understand how to make that decision and how to assess it. Cool. So I'm going to really quickly start with some electric panel basics. If anyone has questions about this, please put it in the Q&A or just, ask us directly live. And then we'll get into, the panel upgrade itself, as well as load management. And then we'll end with some fun interactive activities where we can take a look at the panels that we've received from folks in the audience, and then we'll do a live assessment. So that should be a fun piece. All right, so without further ado, getting into panel basics. Really, when you think about the electric panel, it's typically this square or rectangular box in our homes. And there's 3 views. You can look at it with the cover on. You can look at it with the breaker level once you open it. And once you remove the inside cover, then you can actually see all of the wires behind it. Now, what's important when you look at this panel is there might be a lot going on, but really what's happening is taking a look at that main breaker, which is that big rectangular box you see here on the screen with that 100 labeled with the star. That is going to be kind of the main service to your electric panel and the capacity that that panel is rated for. Underneath, you'll see all of these smaller breakers, which are your individual branch circuits. So what is essentially connecting to your lighting, your appliances, and each of these will also be rated based on the safety of, what appliance it is you're connecting to. And beyond that, just know that these big wires at the top are HOTS that are coming in from the meter, so that the outside meter is feeding your electric panel, and all of the individual appliances are being fed from this central hub, which is your electric panel. So one thing I mentioned, what's really important when you look at the electric panel, the first thing is try to figure out what the panel size or the ampacity of the panel is. And what that means is this is kind of the safe rating of your panel. And you can look at it in 2 different ways. First is looking at the main breaker, which is typically either at the top, at the bottom, somewhere in the middle. It's usually very prominent, and that is going to give you the size, like the total amount of amperage that your panel can accommodate at its maximum. The other way to validate that, and this is usually like the safer way, is to also look at the inside cover and looking at the precise number that's listed to make sure you understand the maximum rating. So with those 2 different numbers, you can triangulate. And the reason we say that is sometimes you'll actually see a smaller number on the left-hand side and the larger number on the right-hand side, and that could be unsafe. So just calling that out. The other piece, and Brian, I'm going to ask you to demystify something. People ask you about the voltage. How should we understand the voltage of a panel?
Everybody has 240 volts coming to their house, and everybody also has 120 volts like in their outlets and their basic lighting and everything. And the way you get 240 is simply by using 2 different 120 volt breakers that get put together. That creates 240. So sometimes people get confused between a 200 amp service and a 240 volt panel, when all of your panels are most likely 240 volts. So you don't need to worry about that. You really should just be able to focus on the ampacity.
Awesome. Thank you. So in other words, every panel has the ability to be 240 volts. All right. Moving on. Okay. So all the appliances in your home together, they make up the total amperage that your panel is drawing. And think of really, amperage as just like the water flow rate. So, the more things you're using, the higher that flow rate. And I'm going to use the word electric load throughout this presentation. So I just want to make sure we're all on the same page. Now, there's the load, which is the amperage, but there's also the actual electricity usage. And that's going to be a function of, the voltage as well as the current. And without getting into the details, I just want to give everyone a visual of how much electricity different things draw in your home. And I want to point your attention to what's on the right-hand side, or what's kind of in red here, which is that your EV charger, your electric stove, your heat pumps, they will draw the vast majority of the electricity in the home compared to some of the smaller things like lighting, your toaster and things like that. And that's an important differentiation, and why we talk about, this concept of needing to upgrade panels when we talk about electrification of these big appliances. The final thing that I want to prime everyone on before we move forward is this concept of a load calculation. So one of the biggest misconceptions when individuals who have no background in this are looking at the panel, if you try to add up all the individual circuit breakers and seeing whether they, somehow match to that overall breaker. And that's just not how load calculation or how load really works within the panel. The way that an electrician might come in and assess the panel and decide whether you need an upgrade is by doing something called the load calculation, which is included in the NEC. And the concept here is just that you're making assumptions about how much electricity each of these individual appliances are drawing, and you want to make sure that the total load is less than 80% of the electric panel rating. So in other words, as you're adding more and more things, if this logic starts to break down and the left-hand side is no longer less than the right-hand side, then that's usually when the electrician will ask for that service upgrade. So keep that in mind, the 80% rule. And just for reference, right, here are some common electric service amperages. We typically see older homes in the 60 to 100 amp range. Most of the newer homes, ones that have experienced an upgrade, are typically 200 amps or above. Okay, awesome. So we covered some of the basics. I try to do that pretty quickly. Hopefully everyone is now on the same page. And now I'm going to turn it over to Brian to talk about, okay, so how do we think about upgrades? And what are all the reasons that the upgrade might happen, and how should we handle it? Brian, turn it over to you.
All right. When do we need an upgrade? If you're going to go way above and beyond what, say, a 100 amp panel might be able to do. Somebody has a very old, large house and it was all gas major appliances, and they want to fully electrify. That might be one instance where an upgrade might just make sense. But using the real world peak demand number determines how much capacity you can actually add before you need an upgrade. And if it's even close, demand management might be another solution. But there's two things that might need you to do some kind of an upgrade. You might not have enough physical space in your panel for breaker space, even if you do have capacity, in which case we can add a sub panel or tandem breakers to squeeze more space out of your existing panel. If your panel is old, rusty, and rotten, your breakers are unreliable, it's in bad shape, you might want to do a full panel swap, but that's still easier than an actual upgrade because we don't have to involve the utility company, and it's considered a repair. So there's a lot of different ways of looking at making adequate space for adding new load.
Okay. And so just so I'm understanding you, you talked about when there's not enough physical breaker space. So, when all of your breakers are full and so you're trying to make room for it. You talked about a case when it could be unsafe and we are just going to need the upgrade regardless. And then let's talk about a third case where it seems like the panel's overloaded based on the load calculation I mentioned earlier. What do you do then?
Well, until a couple of years ago, I would give people a bigger upgrade. I built a lot of 300 and 400 amp services for people so they could add everything they were ever going to want in the future. And I thought I was being very proactive, but what I was building were really big, bulky electric services that were actually bigger than they really needed. In reality, I was doing it based on the math. I've switched over to using real world numbers for peak demand, which is the highest amount you've ever used in the last year or up to. And we use that as your number. And most people are at a quarter where they might be and actually do have room to add things.
And maybe before we get there, because I think we're jumping ahead to the solution, the load management, can we make sure everyone understands what that service upgrade or the panel upgrade actually entails? And again, I want to differentiate between a panel upgrade, which is the physical size of the panel. It could be called a panel swap as well, where you're going from 100 amp
Yeah.
panel to a 100 amp panel, but a physically, bigger panel. Or we can be talking about a service upgrade where we're literally changing the service from 100 amps to 200 amps. So could you maybe tell us a bit more about how the service upgrade actually happens so people can visualize it?
Yeah. A service upgrade is more involved than a panel swap. In the left-hand picture, you see the pipes going up through the roof. That pipe typically gets replaced with a bigger one and new wiring going up to the roof. The entire meter can gets replaced. And that typically has to get a pre-approval from the utility company, approval from the building department. Sometimes they want to look at it first. Then the utility company cuts the power to the house. I have to arrange an inspector that day and then get everything all built and turned back on that day. And that's a lot of arrangements, even compared to the amount of work that it takes to do it. And it makes it a very expensive job because of all of the time that we have to spend. In the right-hand picture, that's an underground service, which means you need to dig a ditch all the way over to the transformer or the pole, which could involve great distances. It could involve going through a driveway or through trees or things like that. And that can get expensive, complicated, and in some cases, borderline impossible, because of limitations on getting transformers or just your ability to dig it and make it bigger.
Makes sense. Makes sense. Okay. So can you tell us then, if I were to recap, it seems like it's a combination of the cost involved in the upgrades themselves. It's also the labor involved from the perspective of the installer, as well as, coordinating with the utility, which can cause further delays as well as permits.
It's the utility and the authority having jurisdiction. They all have to come at the right times, multiple times in the day, in order for things to work. And as a contractor, those are long, stressful days for me. Nothing can go wrong. Once I turn their power off and they cut the wires, I'm committed to it, right?
Yes.
If
Yes.
somebody just has a panel that needs more space or it's kind of old, I can pull the meter out and just replace the panel and not deal with any of that administration. But I'm not changing the size of the service.
Makes
I'm just
sense.
creating more physical space, maybe making it safer if the breakers were old and corroded.
All right. Brett, I think you had a question.
Well, so you started answering, what are some of those ongoing issues of oversizing the panel? And it's not like a heating and cooling system, right? Where if you oversize, you're gonna cause issues where it's, short cycling and humidity issue. It's not like you're gonna cause some kind of electrical problem, right? There's not any other real issue with oversizing, correct?
No, it costs money. If you
Right.
spent six
Money.
thousand dollars on a job, you could have had a less expensive
Yeah.
alternative for that. That to me that's the problem.
Right.
And
Yeah.
also, I think it's more ethical to try to avoid using giant electric services
Sure.
because you're potentially hogging more power in at any individual instant. When the reality, there's not even a lot of benefit in you doing that. You don't have to
Yeah.
run everything at once.
And actually, it's the perfect segue. Well, hopefully, it's okay. I could just bring up this point that when
Please.
individual houses are upgrading their panels or their services, at a certain point, all of that has upstream impacts on wires and transformers owned by the utility. And when we start to, upgrade neighborhoods of transformers, that means more infrastructure and higher electricity prices that are fed into kind of society for everybody to share. And so, in other words, it's not just you or I that's paying for our services today, but in the long term, it can also cause oversizing of transformers and utility infrastructure that's going to raise electricity prices for everybody. I think that's a really important point and one we might not feel today.
Jane, can you just there was one question that says, and the size of the service is an increase in amperage, not voltage, right? So can you confirm
Correct.
that?
Yeah, thank you for that clarification. And so going back earlier, right, we talked about the amperage, which, I was giving the example of 100 amps, 200 amps as being very typical sized panel amperages. And then on the voltage side, 240 volts is the typical voltage limit in a panel. So when we talk about upgrades, it's on the amperage side.
And I just want to chime in because you had mentioned, Brian, I thought you were saying you were studying like a particular client's outputs, right? And you were saying, oh, they only used a quarter of what we thought. So the question is kind of how is somebody figuring that out? I mean, is it you need that, I think on my smart meter, I can log into my account, but I'm really thinking that's only giving me a like hourly power usage. So how is somebody figuring that out?
You are actually on the right track. There's
Yeah.
multiple ways of doing it. I have an Emporia on my house,
Yeah, sure.
so that logs it. That's one way,
Right.
right? Another way, if you have a smart meter, is to your smart meter logs that and it logs your peak demand and it logs it every month, right? So your highest peak demand of the month that's ever been recorded, that's your peak demand, and your utility company does have that information. So the short answer is you can either have a monitoring device or contact your utility company, which is something I'm starting to do now when I'm not sure if somebody really has capacity or not. I'm reaching out to find their actual peak demand number.
Right.
Yeah.
Thank you.
Yeah, and just keep in mind, right, that this is going to differ based on the utility jurisdiction you're in. Some utilities have better data than others, and some are able to share that, and some are not. And so, data is a really important piece of how we get to the answer of what we do. And load management is actually one manifestation of how we use data then to optimize how we use our panel. Since we talked a bit about the basics of the electric panel, we talked about what the upgrades look like. I do want to spend the bulk of the time actually introducing the concept of load management, and we'll actually talk more about this data piece because it really is contingent on knowing what your house is drawing in reality. And so as we get into it, I'm just going to give like a quick definition of how I think about load management. It's actually this very, fuzzy term because it can mean a lot of things, but fundamentally it's two things. In order for something to be load management, it's doing two things. Overall, it's a traffic controller for energy, but the two things I'm talking about are one, the ability for this device to actually monitor the energy usage of the home. So again, getting at the data piece, but the device itself is independently able to capture that data. And secondly, using the data around how much your home is actually using, it's able to perform a load calculation and then determine what needs to be limited, turned off, turned down in the home. So it needs to have the ability to monitor data and then to control energy usage. That's fundamentally the definition of what load management means. Now, you can add all sorts of software, fancy gadgets, different manifestations, UI, and that just depends on how much you want the technology itself to look like. So to give you a quick visual of maybe how this might sit in the home, again, there's a lot of different types of load managers out there, but typically a load manager, could sit at a circuit level, which would mean, it would sit between an appliance like an EV charger and connect into the circuit. It can connect into a sub panel, a main panel. Again, it's usually determined by, what you're trying to add, the configuration of your home, as well as electrical wiring capabilities, where exactly it would fit. And the important thing for monitoring is that most load managers have some way of accessing the HOTS that I showed you earlier, which means that it can monitor using these sensors how much energy your home is using. And then the device itself typically has some sort of relay system or a software control that would enable the appliance to be shut off or turned down. So that's how you can visualize load management. To give you a clear example, so you can visualize how, an example of load management, so what a stepwise device will look like, for instance, is that it could be mounted, again, anywhere between the circuit and the appliance and the breaker. The key here is that it needs to be able to work with and without internet. So when it's installed, the electrician would make sure that that it's wired correctly between the appliance into the panel. But there's also a commissioning step, which allows the data from the device to be tracked on some sort of web portal, web app. And then for the commissioning itself, it means being able to connect the device to internet as well as any other appliance integrations. And I think what's really important though is that even without internet, this device can work as a safeguard, an electrical safeguard. So even when you lose power, even when, for some reason, maybe a Wi-Fi extender was removed and you can't pick up signal, the device can always ensure that your panel never exceeds its safe limits. And that's kind of the beauty of the load manager, because it can automate the load calculation and make sure that your electric panel is safely guarded. And most of these are also easy to install. The tap, for instance, is less than 1 hour to be installed by a certified electrician. We typically do recommend that someone certified does this to make sure it's done correctly and to be able to pull a permit accordingly with the AHJ. But some savvy DIYers can also do it themselves. All right, a quick illustration about how this might work. Let's say this is your panel and you're, turning things on. This is an example with an EV charger. You're like, shoot, when I plug in the charger, I do the load calculation, it's going to clearly exceed the safe limits of my panel, that 80% rule. With a load manager, for instance, if it's connected to the car, it would automatically dial down the draw of your car for that 15-minute interval when you're at that 80%. And so the system can automate that process to ensure everything stays within the panel safe limits. And again, you can mix and match, use this for other appliances.
Jane, does the charger itself though have to be some sort of special charger to make that kind of communication?
Good question. Yeah, typically for the ability to integrate or communicate with a charger, it would require the charger to have intelligence of some type. So typically, in the world of chargers, it could be OCPP or some sort of, like Tesla API that would enable that more seamless communication. If it's a dumb charger that you're talking about, this device would just act as a dumb, on-off switch. So it would still work. It just wouldn't be able to communicate with it to dial it down.
Okay, so it would just simply turn it off, not throttle it back, right? Is that correct?
Correct.
Sure.
Correct.
Thank you.
Yeah, no problem. And again, that example can be applied to any dumb thing in the house. Most of our dryers are dumb. We might have a dumb hot tub. All of those things can also be controlled by load managers, where it would function as an on-off switch. All right. I'm going to turn over to Brian because this is his favorite part, where we're actually looking at real versus calculated loads. And this is the data piece that we keep talking about.
Yeah, my house and shop, I have a home business and a shop attached to my house. I originally built it on a 400 amp service so that mathematically I could do everything I wanted. And then I put an energy monitoring system on and realized that my house, which had its own dedicated 200 amp service, pretty typically never went over 54 amps. And that was briefly when I did laundry. My shop at the same time typically drew about 9 amps most of the time, unless my car charger was running. And I was able to combine my house and service to a single 200 amp service and use one EV tap. And monitoring, I'm still not typically approaching 100 amps with 4,000 square feet of house fully electrified and a Tesla charger at 60 amps. I rarely go over 100 amps at all. And that really blew my mind because I thought I needed mathematically a 400 amp service to do that, when technically a 150 amp service would actually work based on my actual consumption. If a different family moved in and ran the house differently and used stuff more all the time, that number would be bigger. But I'm still really far away from my limit. So like at any given hour, my house is typically, and this was at like a cold time of the year, my house is at about 15, 18 amps total on my 200 amp service. Yeah. So that's a real, but the number that the building inspectors care about and the electrical inspectors is just the top number. And if we look back through the year, that peak number is my actual worst case scenario. And that's what we call my real number. And based on that number, I could add more capacity without even using any demand management. I could still add something else.
And Brian, out of curiosity, do you know what the load calculation on your panel is? So if you didn't look at the actuals, like what would the load calculation turn out to be?
It would tell me I needed a 300 amp service.
Yeah, exactly. And so this
It
is
would be like
actually very,
220 when my limit on a 200 amp is 160, right? As soon as you cross 160 mathematically, you'd have to now do an upgrade to something bigger.
yeah. And
When
I
my
think one
real
of
world
the,
number is probably 105, doing laundry, charging my car, everything. My demand management device at that point is just in case.
yeah, no, I think this is such a great piece of insight because I think this is one of the biggest misconceptions when you do the load calculation because of how conservative the estimates are and the fact that you just don't know the actuals. You have no choice but to to upsize and to just make the worst case scenario a reality. Whereas once you actually see the data, and we've installed now hundreds of these devices across and have seen the data, it's very clear that most people don't use anywhere close to their electric panel capacities. And so load management right now is a gateway for lots of regions where the data is not necessarily always available, or where HJs are still a little bit hesitant to purely trust that data because you're in a cold region, or there's just other uncertainties. It's a safeguard to make sure that we can actually tap into the remaining capacity of the panel without oversizing. So thank you for sharing that. And this is not just Brian, it's many, many homes all over the country. So a quick note on code compliance. I do think that it's worth calling attention to the section of the code that this fits under without going into too many details. Energy management systems, or really the other term for it is load management, is the reason why a device like what we're talking about is able to enable an installation as well as pass inspection. And so all of this is code compliant and it's within the NEC. The only thing is, right now there are sometimes devices on the market that are not actually listed and tested by a national lab. So just make sure that you're looking for solutions that are certified. All right, now going into some of the benefits. I mean, for consumers, Brian mentioned earlier that it could be more costly, it could take a lot of time, a lot of labor. And the reality with load management is that it's just easier, faster, and it's safer. Brian, I think you had some good examples that you wanted to bring around how it might be faster and how it might be safer in particular.
Yeah, faster in particular is easy. If somebody's trying to make up their mind about how they want to create capacity to say add a Tesla charger or something, um, if I want to do a service upgrade, they have to approve the estimate. I have to pull the permit, call the utility company, wait for permission, do all of that planning, and then actually do the job and get it inspected. But then I can add my car charger. Versus if we add a demand management device, I can, as long as I have the device, I keep an extra one on my shelf. I can do the job like the next day. And it doesn't even matter if their panel has capacity or not, because I'm simply going to create electrical capacity. If I have to
I love
make
it.
breaker space some way or another, that's a slightly different thing, but that's not nearly as complicated as a service upgrade. That's just some electrician tricks, just to create space. We can create capacity with demand management or by making it bigger with a service upgrade, but one is a couple hours of job that doesn't need the utility company.
Makes sense. And then on the price point, what is, I know you're in Ithaca. What is the differential that you would see between load management versus service upgrade?
Um, I sell a load management device with the device plus all of the labor for a little over $1,000. And
Awesome.
service upgrades are, $4,000 to $8,000.
Yeah. And I know I've heard crazy numbers around the country, like in parts of California where you have underground trenching involved, like the underground service we mentioned earlier. It could be in the ballpark of like 10 to 20K. Even that is not out of the
Yeah,
question.
yeah.
Yeah.
And you might have to like patch your driveway or repair concrete or, things along that line. A lot of times I have customers abandon their underground service and just go overhead at that point because it's just
Yeah.
not even practical to dig it. You could be in a shared community where you can't really make your service bigger because there's a bunch of apartments clustered together. It's just not even an
Yes.
option. So you can create capacity then when the upgrade is just not practical for any amount of money in some cases.
There's
Makes
a
sense.
question in the Q&A about is there a lifetime on I'm assuming they made load management devices. Do they update automatically or have to be replaced every, say, 10 years or something along those lines?
Yeah, good question. So I would treat the load management device, since it's a physical piece of device, like a hardware thing, similar to any hardware electronics you might deal with. So panels typically have a 10-year lifespan, and I would say there's nothing about the load management device that would make it fray or not work for any period shorter than that. But it is a physical thing, and so like I think 10 years is probably a fair assumption. In terms of upgrading or updating, when you deal with load management solutions that have intelligence, so internet connectivity, most of them also enable what's called over-the-air updates. So from a firmware software perspective, you can actually update it virtually. The limitation is just on the physical hardware itself. Okay. And maybe just to quickly touch on safety, I think we've already talked about it. Again, you want to ensure that you're never at the point where you're physically overloading your panel. And so the load manager is just a really good piece of safeguard. It ensures there's no electric fire, and that there's peace of
And
mind. Okay.
there's another one, which are load management devices universal in terms of voltage across world zones? I don't know. I think we have mostly a US audience here.
Yeah, I think the differentiation is probably between residential and commercial load management. Right now we're talking about residential load management, and so we are dealing with 240 volts because that's the world of residential. And the reason why I don't include 120 volts is because you would never really struggle with a 120 volt appliance triggering an upgrade or even needing any type of management because it's just such a small amount of electricity usage.
Um, so I think I was curious where solar power and or battery systems come into play with this conversation. Is there any connection between them? Any tips and tricks to consider with that, or is it just sort of, hey, these are generation or storage? It's not really interconnected with this.
It absolutely does. And I think that's why I started with load management is a broad concept, but there's kind of these two features. And it is applicable to the world of storage and solar. And like it's just a little bit different from how we're framing it today. So for instance, when you talk about solar storage, maybe even generators, you're talking about backup energy that is feeding the system. Where load management is used, again, in the traditional use case that we just talked about, is it's basically deciding what to prioritize and what to deprioritize, right? In relation to the total. So
Mhm.
similarly, for solar storage batteries, we're also thinking about what you want to prioritize and deprioritize. In a world where if the home loses electricity and now you're feeding on your battery, well, maybe
Yeah.
you don't want your EV charger to be the first thing that's, charged because that might
Yeah.
not be the highest priority item in your home. So load
Yeah.
management in those contexts would be around how do you actually decide what you are feeding
Yeah.
first.
Yeah, and I know for me, like I've got battery and solar, and they're quite that they're like, do we want to have this sort of, and I forget the critical load panel, right?
Yes.
Do you want that so that way your power goes out and it's only these things? And I'm like, but then what if I actually wanted those other things on there and I wanted to make my own decisions and not be beholden to this critical load panel? And they're like, well, then we don't put it on one. I'm like, okay, I'll do that. But now I'm like, what if my power goes out in the middle of winter when I'm on a heat pump and I've got an EV charging and now I have this massive load on the battery? Not good. So does something like this say, hey, the power just went out. Now we're going to throttle back these other things while still allowing them to be on the battery and not be, thrown off of it based on these critical load panels that give you this sort of black and white choice.
Yeah, it's an excellent example. And I think
Yeah.
something that a lot of people worry about. So Brett, absolutely. That
Yeah.
that is how load management would apply for solar storage batteries and generators.
Yeah.
I know we're not pushing for them, but people use them.
Right. Yeah. People, and I meant any generation, yeah. Yeah. So, yeah.
Yes, no, exactly. It's about how do you prioritize or deprioritize, but still allow the system as a whole to feed off of it.
Um,
Thank you.
Another kind of line of questioning where there's a couple, is the load manager similar to a smart panel or smart breaker? You may be going into this later, Jane, where you compare it. And, one of the people are mentioning one of the better known brands, the Span smart panel. So I think just looking to understand where load management fits in compared to those two things.
Yeah, yeah. And so again, going back to my definition of load management, a span panel or any smart panel is also an example of load management. Because again, the two distinguishing features are collecting data and the ability to control, right? And so a lot of the solutions, and we can, if people want to discuss different options on the market, there's a whole range of different products that are applicable as load management. They just fit in different parts of the home. It could be a breaker, it could be a panel, it could be, kind of like what I described, which is circuit level, but not the breaker itself. It could be on the meter cover, it could be a switch. Like there's a lot of different kind of form factors that load management can manifest as in the home. And the way to think about what to use is based on purely the use case. Like, what are you trying to do? A span panel is great if you're trying to do a whole home project. You're touching multiple, appliances, as well as solar, and you want to upgrade your panel. Like it's great because it allows you to control every breaker. If you are trying to pursue projects more one-off, it's more of like home renovations, DIY, you're just improving kind of the state of your home. You may not need or want something that is holistic and has holistic controls. And so it's really about just picking and choosing what might make the most sense for your journey. This is actually a really great segue because the next two slides, Brian, I know we wanted to talk about when to use load management and when not to. And so we can paint a picture around some of the specific use cases that would be good applications and when you should probably just veer on the side of safety. So I'll turn this over to you for when to use load management.
Yeah, I think it kind of comes down to where load management is great when you need extra capacity only rarely. Every now and then you might happen to be doing laundry and cooking and vacuuming and microwaving and toasting, and yeah, you need to turn your car off. But if you take that house and you add an in-ground pool and a hot tub and some other things that are going to run frequently and use a lot of power, you really kind of just need more power. Unless you're just on the edge and that one thing is tipping it over. If you have multiple things tipping you over the edge of being too much, it might be better to do a service upgrade so you're not load managing things too frequently. You could load manage a hot tub, but I wouldn't want it turning off all the time because I also had a bunch of other stuff too, right? That's good where it'll probably almost never get used and it's just in case. And for most people of demand management, that really is what it is. The vast majority of the time, they're well under their safe limit and it's there just in case. So a really large house, somebody might have 5 different heat pumps running, water heater, and all their appliances. You get into pools, welders, commercial shops, as people start adding other equipment. They legitimately just need more power now. But that's very non-typical.
Yeah. So I think some of the thresholds that we put out there are you almost literally never need a 400 amp upgrade. Again, unless you're talking about one of the edge scenarios that Brian alluded to, you literally have 5 heat pumps and you have a pool and you're a welder. We can also mostly say that you can enable whole home electrification for most homes that are not McMansions on 150 amps. And I think Brian's data actually showed a very good example in a cold climate area. And then, of course, the installing one-off installations. But I think it's equally important to address when you should absolutely get an upgrade because load management is not a replacement for a physical panel upgrade. We're talking about increasing capacity versus the physical nature of a device that will just become obsolete over time. And so I think it's also important to point out that there are certain types of panels, maybe they're damaged, obsolete. There's certain brands that will need to be upgraded because they're not code compliant. or if it's just a severely undersized service. Like I know electricians sometimes will go into a home, see that the load calculation itself is like, I mean, the house itself is already non-code compliant, and adding anything else could actually lead to electrical fires. In those cases, you don't want to just make room and be smart. You want to do what's safe. So I think this is a very important note. And then finally, I did want to add a couple of additional bullets on rebates, since that's a point that we often get questions about. And I think on rebates, it is a hodgepodge depending on the state, the city you live in, the utility that services you, as well as obviously the federal piece. State and utility incentives are going to be extremely varied, but typically, if you look at load management as kind of keywords, or if you just look at whole home electrification, even like demand response managed EV charging, you might find some incentives related to this concept that we're presenting here. In California, I think this is amazing. There's literally a rebate if you can fully electrify your home on a 100 amp panel, because they're trying to push load management as a concept in order to decrease overall infrastructure spending on the utility scale. On the federal side, there's also a couple of rebates and incentives that people are probably familiar with. So you have HERA and you have the energy efficient home improvement credit. The important thing here is you can use both of them, but you can't use the two buckets for the same dollar. So in other words, a portion of the spend could be covered by HERA, and the other portion of the spend could be covered by the 25C, but you cannot stack them where they're literally funding the same dollar.
Yeah, and I just wanted to chime in on that. There's actually a great resource to see if your state has the rebates approved. Unfortunately, it appears to be down right now, but I'm putting it in the chat. It's Atlas Building Hub home energy rebate trackers. So that'll give you a sense of where your state's at. But here in Michigan, Indiana, our good friends in Wisconsin and the Midwest, they're all moving forward. So they do fund a full breaker box. They'll fund a whole breaker box, but a lot of times that takes, as Brian pointed out multiple times, a lot of cost away from your project. So if you can do something like this, which should be approved, you got to check with the state. You can, then reserve those funds for something else, especially some of the older homes they have. What's it called? The old electric that's not safe. I know what it is, right? The old kind,
You
right?
mean knob and tube?
Knob and tube. Thank you. I know it. It just was gone. So, you might be able to use some of that funds to fix something like that, which Brian, I'm sure you can say is not going to be cheap in most cases. So it's just kind of shifting the funds and using them. Again, check with your local state. Even though these are federal rules, I tell you, every state has a different way of interpreting them. So just check with that. So
makes sense. Makes sense. Okay, awesome. I mean, we've gotten through the bulk of the content portion, and what we want to do next is actually try to apply some of what we talked about on real panels. And before this session, I know Brett sent out a message, and many people actually submitted photos of their panels for a live assessment. And so Brian and I are gonna walk through. I think we have about 4 loaded up, and if we have time, we can cover a few more, where we can just talk about how to look at the panel, how to think about it, and maybe what you can do with that panel. Okay, Brian, ready for this?
I'm ready.
This is the fun part. Okay, so we picked a few prototypical ones because these ones all kind of have different dynamics to them that we want to make sure we can cover. Okay, so let's walk through this one. Brian, I know it might be hard for you to see on your phone, but this one is a 100 amp
I
panel.
can see it.
Okay, yep, perfect. Yep. Yeah, I'll let you take it away.
That particular panel is probably the single most common panel that I've generally seen over my career. In a lot of cases, they've been upgraded now in the last decade or two, but an extremely common 100 amp panel. The way it's loaded up at the moment, it's got a little bit of available capacity in it, most likely.
How do you know that?
I'm looking at the larger loads that are in it, but I'm not spending a lot of time analyzing it. But it might have a low capacity. Maybe you could add an electric water heater to it, for example. Over the, I see a water heater, but that might be a power vented 110 volt gas unit. I would guess. Uh, but my quick assessment is it looks healthy and clean. It's in a dry space. It's not rusty and nasty. There's nothing wrong with that panel. It might be running out of physical capacity. It might run out of electrical capacity, but it doesn't inherently need to be upgraded. If somebody wants to add a car charger or something to that, that would tip it over the edge, demand management will be perfect because it'll definitely fit. And we don't even have to do the math to figure out if it's already overloaded or not, because it won't allow the car charger to run if it's overloaded. It'll work.
Yeah, and actually, on that note, I wanted to bring up one point or tip in thinking about load management. Some electricians have used this phrase, and I think it's really clever, which is that the load manager is essentially canceling out whatever load you're adding to your load calculation. So whether it's a water heater, a heat pump, an EV charger, when you put a load manager on it, it basically cancels out that load from the load calculation. So that's kind of your little trick.
Yeah, from the building department standpoint, if they say, did you do a load calculation? No, but I'm only adding 0 to it because of the demand management. And they say, okay. And that's all the math you got to do.
Yeah.
They're not
Love
going to
it.
make you solve it if there's something else and it's already overloaded. You didn't do that. That's not on you, right? It may or may not be overloaded. You can skip the math and simply say it'll definitely work this way.
Yep.
And that's what I really like about it. And for people who don't want to do long, complex mathematical calculations, which even contractors tend to dislike, they'd rather sell you an upgrade in many cases than do the math.
Yeah.
So
Totally hear you. Yeah. Well, thank you for sharing. Can we maybe move on to the next one? Because I think this one
Mhm.
is also a very common scenario where it's a 100 amp panel and it looks like it's full.
Yeah, it's a little full. It's even got a tandem breaker, so they've already created one extra space in it. Um, it it may or may not be capacity overloaded, but similar to the other one, it doesn't look in bad shape. There's nothing wrong with it. It's perfectly safe and functional the way it is. You could add a couple tandems to it to create physical space, or you could add a sub panel to it to create physical space. And then if your load, if you wanted to add a car charger to that without doing the math, I would add a demand management device because it'll definitely still work on that 100 amp panel. We just need room to put it in.
Brian, how would you know if there is capacity? Because you basically said, probably has capacity as is without needing a load manager or anything. Like what kind of again, we're not doing full load calculations here because we're kind of talking about this live, but like what is your
Yeah.
sort of rule of thumb?
If I see that somebody has a stove and a dryer and a hot water heater already on a 100 amp service, it's full. That's right up to the edge of what you're allowed to put in it. And honestly, that's reasonably fair. If you're cooking and drying and making hot water at the same time, that doesn't mean you can't add a car charger. You just can't pile it on top of all of those running at the same time. Most of the time, it's only one of those things going, and you could run a car charger at the same time. And, you know, I like to think of a demand management device kind of like it's just a smart switch. It stays on as long as it can. It doesn't matter if it's connected to the internet or not. It just knows what you're doing. And if it can be on, it is. Otherwise, it's not. And it does it automatically, which is what makes it smart. Not because it's Wi-Fi connected, because it's automatic.
Makes sense. Makes sense. So in this panel, I guess you're saying there aren't really many big loads.
They're not.
Yeah.
But you probably still don't have 60 amps of available capacity for a Tesla charger. The minimum
Yeah.
load in the house for lighting and everything is not nothing. It might be like 30 amps, you know. So if they happen to even turn on their microwave and one other thing, it's going to turn the car charger off. That's fine. And it's going to
So
turn it off for like a couple minutes and then turn it back on again. They'll never know the difference.
makes sense. So it sounds like the verdict is like this one, there's a good chance that there's remaining capacity for something, maybe a heat pump. But if you wanted to add
Yeah.
like a very large load, like an EV charger, you might be kind of right there, or you might definitely need to consider a load manager.
Yeah.
Yeah.
I find high capacity level 2 chargers, which are 50, 60 amp chargers, are the biggest loads anybody's ever going to add to their house.
Yes.
Because it actually draws it draws 80% of that number. A 50 amp heat pump will probably, in my experience, never draw over 20 amps. But a 50 amp car charger will draw 40 every minute it's on.
Yep.
So if you have a monitor, when you watch your car charger turn on, that number triples, quadruples your total consumption in your house while it's running, pretty typically.
Yeah.
So,
And you have the data to back that up from what you're looking at in your own home. So very
yeah.
cool. Okay. I want to move on to a sub panel orientation because this is also very common. Again, I think this is kind of a weird one where the sub panel is literally next to the main panel. We typically see more distance between them, but regardless, right, it's the same thing.
Well, if the top panel is just crazy full and you need to add like 10 more things, that's what you do. You add another panel with 10 more spaces. And that now their bottom panel still has a couple more spaces that they could add. So they created a bunch of extra space that they needed. You
Mm,
know, some houses don't use a lot of power, but they still have like 40 breakers. It's because that's how modern code has you wiring house, where your refrigerator's on its own circuit. You can barely even see it's on. It draws so little. And a lot of things have
yeah.
0 amps on them at any given moment. In fact, most of them have 0 amps on them. So you could have the tiny electric bill and barely any consumption and be completely out of breaker space. That's the complete opposite of running out of capacity, where you're drawing too much power and you need more. So uh, the second
How,
panel is the best way to think about it is it's a continuation of the first one. If the first panel is 100 amp and you add a 100 amp sub panel, it's still 100 amps. They don't add together. You're just creating more space off of the first panel because that first 100 amp breaker is your major restriction, right? And if you draw more than 100 amps on a 100 amp panel, what it's going to do first is actually just turn the main breaker off and your entire house is going to go dark and silent.
mm, makes sense, makes sense. Okay, so let's say I wanted to add a water heater on this. How would you go about that? What's your recommendation?
Well, well, there's physical space in the bottom panel, so I can pop a breaker right in without having to modify anything. So that's nice. Um, I'd have to figure out what the actual consumption is on that service to see if they have space for that new water heater. And if they do, it could go in just like it is, just wire the water heater. If we find
Hmm.
out that they're over their limit, if you add the water heater to their old peak demand, then we add a demand management device because that'll stop that water heater from ever overdrawing based on the amount they're actually using in their house. You know, within the last year, you've peaked, and that's the real number you want to use.
Makes
We're
sense.
we're also getting a question about electric, or just a comment, which I could think is a good one. Electric readiness also includes EV charging. I don't know that we've really
Yeah.
spoken about that use case much, and since load management is so good for that, I just want to bring it up. It looks like Brett has something to add as
Well,
well.
yeah, no, thank you for bringing that up. And I wanted to let you all finish if you had more, but I did want to bring that up because the comment to kind of add to it was, this is getting electric readiness is getting into codes. It's in some of the green building certification programs. And so their question kind of is like, you know, how do we confirm to the code official or the green building rater, I guess, how we know that something like this is meeting that? Like, have you seen anything like that?
And when you say something like this, are you talking about load management or just
Yeah,
data?
sorry. So let me say it another way. Can load management solve the electrification ready panel upsizing mandates or green points you get in the certification programs?
Brian, do you know the answer to that?
Yeah, it allows somebody to build a house with a smaller panel and still build it with the intent of a 50 amp car charger, which is a standard expectation now. They want you to put a 50 amp outlet in the garage. Well, you could maybe take a 150 amp service and put a load management device on it and still add a 50 amp plug. It's fine.
Yeah.
You don't necessarily have to go to 200. So it allows that service to be smaller, which is less expensive on the front end to build while still allowing that readiness.
Yeah. And I think, Brett, there are a couple of sections of the NEC we can send along as
I
reference. Right.
Yeah,
Because like the one I showed earlier, the 750.3, that
yeah.
is basically the section that allows energy management to supersede the load calculation.
Right.
But
And
then
that,
there's
yeah,
sorry, but there's also a section specifically for EV charging.
yeah,
And so I don't know the exact number off the top of my head, but if that's what
yeah,
you're asking for, then that's something we have shared with inspectors in the past, which has
right.
helped to, yeah, comply with code.
Yeah. And so, of course, that is the question is like, are those things getting codified in the states or are they throwing those parts out? Or even when they are codified, right, the inspectors still just go, oh, I'm just looking for that breaker. And if I don't see that, no way. So then do they need education? Do they need training? And so that's a loaded question for another time, but it just sort of,
Yeah.
is anybody seeing concerns with that, I guess?
And what I will say is, we have talked to and installed over 25 states across the US and all the heavy hitters, you can imagine. And we have not experienced true pushback other than, wait, I'm not sure what this is. And once you explain it to the AHJs, then they understand. And so, in other words, like I think there's going to be a little bit of a phasing in of this education where it might be a little bit more, instructive. You need to share a one pager or have a conversation. But because it's already codified in code, it's
Yeah.
just a matter of making sure the inspector's aware.
Yeah. And that brings up another point that someone brought about how this is required in Oregon and multifamily. How would you approach this in a multifamily setting, if at all possible?
Yeah, multifamily is actually pretty varied. Like you have large condos, right? Like think New York City skyscrapers. But
Yeah.
it can also be, a triple decker, 4 unit building.
Yeah.
I would say this is where, you might have to think about the exact application and the specific product that is suitable. For a typical residential application, it typically includes single family all the way to kind of 4 to 5 unit buildings. So like terrace buildings, triple deckers, like those are still kind of within the realms of residential. And there's a different kind of product category that's typically used in more of the commercial multifamily. So again, talking about large condos. And the best way for me to kind of give the TLDR is based on just how electrical is set up, you know? And
Mhm.
so in the smaller multifamilies, individual homes are still kind of like the single family, but you might
Yeah.
have like a shared meter or panel of some sort. And so you could still install the load manager in the same way adjacent to that panel. In like one of those big condos, you're dealing with just a totally different kind of electric mix for parts of the building. And so
Yeah.
it's going to depend a little bit on the building. And it's a little hard for me to make a blanket statement.
The rules
Fair
are going
enough.
to be different for single family home readiness versus a complex readiness.
Yeah.
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 Um,
The other thing that makes building inspectors happy is the UL listing on the actual device. It's not just you're
sure.
allowed to use a device, it's been tested and approved for that purpose.
Fair enough.
So
Yeah.
when they see the combination of the code plus the UL listing,
Yeah.
that's it. That's all their questions pretty much at that
Yeah.
point.
Yeah.
Yeah. And
Um, well, go ahead.
go ahead. Oh no, I was gonna say we're basically wrapped up
Yeah.
on this part of the presentation, and I know we're already over time, so it might make sense to get into Q&A. There was one
Yeah.
more panel, but I think we get the point. I did want to say that there are a couple of tools that we're happy to share with folks on the call that might be useful as
Oh,
following
cool.
up to this conversation. But in any case, I think it might make sense just to go to Q&A and see if there's further questions we can help address.
Yeah, yeah. Let's get to those questions. And before we do, just a quick reminder that the answer is yes. This session is being recorded, and you can check back on our YouTube channel here in the next week or so. It should be posted maybe sooner, or you can go there right now, click subscribe, hit the bell, and you'll get an instant update when the session is posted and available to rewatch it or share it if you want. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate to receive your continuing ed certificates on wherever you're taking this quiz. And for those of you here live today, as long as you've been here for the entire CEU approved hour and you've been appropriately logged in, take that survey that pops up at the end or is emailed to you. Give us your feedback. We'd love to hear from you. And then look for your certificates from certs@gutenbergcerts.com for that. And again, as those questions are coming in, a huge thanks to our board of directors, our volunteers, our executive director, Jose. Raina, our nearly 500 members. We want to get to 500 here before the end of the quarter. So help us if you haven't yet. And also all of our sponsors who are helping decarbonize and, adding electric load in many ways with Ream and um, Panasonic and Serve. And so could be helpful to look into this to help incorporate those products into ultimately what you're doing. So, I wanted to there's certainly a lot of conversation and question. I want to kind of go back to one about sub panels. Does adding a sub panel increase total capacity or just space? In other words, could you add a 50 amp to a main panel that is 100 amps by adding a sub panel?
The short answer to that is no, it does not. 100 plus 50 equals 100
Hmm.
of total capacity. What you did do was create 50 more amps of available capacity in a different spot for breaker locations. The total is still limited by the first weak link in the chain, which will be your main service.
Hmm. And then another one, is there a way to calculate how much electricity is continually drawn from smart appliances, which are constantly drawing energy? So what I think they're saying is this vampire load. We've always talked about that, right? And does this load management, I guess, help people understand how much energy is being just sort of drawn in devices when it's not on, or is that really just something different?
It's a good question. It depends on where the load manager is sitting, I suppose.
Hmm.
Most times, if you're talking about like an appliance level load manager, you can probably capture the full home energy data as well as the usage of that appliance. It would be
Hmm.
hard to attribute, this is exactly what every single thing is using to any degree of accuracy. You can make some guesses, but it's not going to be fully accurate. So I think it's like, yes, on a high level, you would know how much the home is drawing and you would know how much, the appliance that's attached to the load manager is drawing,
Hmm.
but it would be hard to disaggregate that for every single load in the home.
Hmm. Um, and I think to add to that question, there just were some questions, like again, people wanted to get some clarity, like if they have that electric utility smart meter, how are they using that to determine, their loads? And then someone was like, what if I don't even have my electric utility? Maybe my electric utility didn't do the smart meter, or for, whatever EMF reasons, if someone's concerned they're not doing it, that's fair.
Yeah.
What EMR, I think they call it now. But how do they figure this out?
Yeah, I mean, the reality is, I think AMI deployment is about 50% of the country, but only something like 20% of the country has access to data that
Right.
is, accessible and usable. And so, the alternatives are what Brian alluded to earlier. One, you can put in an energy monitor. So like
Mhm.
just a device to track energy usage.
Mhm.
Again, it's used sometimes, but it is can be quite tedious because you have to leave it on for a period of time.
Yeah.
Another option is to again use the load manager because it's also being an energy monitor while also
Mhm.
controlling your appliance. And then the third option is you can try to fight with your utility for the data. Some people do go down that path. It just involves a lot of manual efforts.
Yeah. And then here's a great question. If people have, air conditioning systems do this, air source heat pump systems do this. I would imagine ground source heat pump systems do it to a much lesser extent, which is this person's particular question, but I'll just throw them all in, right? So anytime these devices fire up, they have a startup phase and then they tamper down. So where does that come into the load management conversation? Because it almost seems that anything you're doing, you're really beholden to that startup peak because it has to start, right? You can't not start it. So how does that come into the conversation?
Yeah,
Well,
there's. Oh, Brian, go ahead.
Yeah.
I was just going to say, almost all of that modern equipment you just described is now using inverter technology, and they
Right.
ramp up slowly. There is zero spike. When you
Mm.
just slam a motor on, it draws 10 times its normal power for half a second. Pretty typical. It does it so quick, it won't trip the breaker, even though it goes
Mm.
way over the limit usually. but it's still a real number that counts,
Yeah.
and the utility company has to deal with that. Heat pumps now, they all ramp up really slowly with inverters. And even the weird brands that nobody has heard of, they're still all using inverter technology now, which is how they also control the fan speeds and the motor speeds. So
Um,
fortunately, that startup isn't very substantial, except for something maybe like your well pump, but
yeah.
that's like 3 to 6 amps. So its startup is 10 or 15. It's not like a very high number. So for most houses, that startup cost is no longer of a particular concern.
Yeah. And maybe to add, like in the event that you are in a house where that is kind of a concern, the way you can think about it is as long as at any moment your total load is not over that 80% rule, you're still safe, right? So in other
Mhm.
words, let's say the startup is, a second, you could always deprioritize something else in the home with load management to make room for it. Like that's how the system would function in practice, right? It would be kicking in to ensure that everything stays within safe limits. Again, it's
Mhm.
not very common to Brian's
Yeah.
point.
Yeah.
If something goes over the limit, the load management device, in probably a fraction of a second, is
Mhm.
just going to go too high and open the switch. It doesn't have to think very long. It's not a very long delay. And your electrical devices, let's say you put 105 on a 100 amp breaker. That doesn't
Mhm.
immediately cause it to trip or immediately cause it to burn, but it can't stay there for very long. The load management device will turn it off very quickly before that time delay kicks in.
Yeah.
So even if you exceed safe levels for a second, that's
Yeah.
fine.
Yeah.
It's meant to absorb those kinds of overloads, just
Yeah.
not for durations. We don't want to sit it for 4 hours over that limit.
Yeah. Um, Two great questions kind of came in, and I think, we've been speaking to them, but just to kind of hone in on them, you know, I think it's the idea of using past demand and making assumptions based off that, but then assuming the future is going to be different in the sense that you're going to change your home. And so the question is kind of like, I'm using the past data, but really the future is different. And then the other question is, how are we using this data to size our battery needs? And so I don't know if you want to kind of take those questions together, if they're two separate things. So,
Yeah, I'm happy to take the first one if Brian, you
yeah.
want to take the second one. So on the first around kind of predicting sort of how this energy data will evolve, the reality is our devices are actually getting more and more efficient.
Hmm.
So if anything, there's kind of a net cancellation between, more things are electric versus each individual thing actually uses less overall electricity because they're more efficient. So I think that, looking at past load is helpful to understand behavior. Like when are you using different things? Um, and you can use that data as a starting point for thinking about, okay, what additional things do I want to add into the home? But also know that as you're, replacing your appliances as they're approaching end of life, you're actually maybe replacing them with more efficient appliances. So your baseline actually drops. So there's a little bit of that cancellation effect. So hopefully that's kind of a helpful, like pragmatic way of thinking about it. On the battery point, Brian.
Yeah, on the battery point, you're not necessarily sizing a battery based on your peak demand as much as how much capacity you're trying to get out of it, right? Um,
I mean,
people
would
might
it be
want to,
fair though? Because you're trying to do both, right? Because you certainly want to know how long it's going to last in an outage, right?
yeah.
Especially in an extreme cold, extreme heat or extreme cold would be even worse. But then also you want to make sure, right, that something doesn't trip it, right? And because that knocks it out, and they tell you not to do that, right? So,
Oh, I would say you would want the system to not probably charge your car when the
right,
power's out on your home battery.
sure.
So the the battery systems themselves and the panels that are connected to them very
Mhm.
often have some controls, so it doesn't just automatically try to run your entire house.
Yeah,
You want it to run one panel that's dedicated with like your refrigerator and your Wi-Fi,
yeah.
not not like your dryer.
Yeah.
Yeah, well, and actually that kind of makes me think like how much, if it's a quick answer, how much does something like this intercede? So if the power goes out, does, an add-on to, this solution sort of go, hey, we're going to quickly take it down real quick before the battery gets overwhelmed?
No, that's exactly it, actually.
Yeah.
That's exactly it.
Okay.
It's basically when I say earlier, like deprioritize, that's
Yeah.
the impact,
Like it's
right?
just real
So
fast, right?
yeah, exactly. Let's say, okay, I don't like to Brian's point. I don't want my, backup battery to be charging my car. And
Yeah.
so, when power goes out, you would make sure that the car charger is deprioritized. There's actually like load management within the generator world that has actually existed for a long time. And that's
Yeah.
exactly what the use case is.
Sure. Yeah, that makes
Yep.
sense. All right. Well, we are at the end of our time. So again, a huge thanks to you, Brian and Jane and Holly, who's been behind the scenes helping people answer questions, and to Stepwise. Can you just remind us again where people can go to learn more and get more information?
Yeah, sure. I've included contact information for both Brian and I. With Stepwise, our website is getstepwise.com. You can
Yeah.
always reach out to me directly at jane@getstepwise.com, or go to our website. There's a lot of forms where you can, put in your questions.
Mhm.
Feel free to also connect with me on LinkedIn. I'm under Jane Chen 3 since my name is quite common, but would love to stay in touch. And if anyone has any questions, like I think that this world is evolving rapidly, and I would love for all of you to be a part of this dialogue and for you to be a part of the solution as well.
Yeah.
Thank you.
All right. Thank you all so much. Take care. And we'll catch the rest of you same time, same place next week. So goodbye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.